Well, thank you very much, Paul. That was a fantastic talk, and I think this is the second time we hear that we've got an enormous challenge ahead, and we can all agree that a whole of a nation challenge, isn't it? As Paul Madison mentioned, and we are lucky in Australia actually that we have not one but two universities that are ready and primed to provide some of the education and training which is going to be needed. And so we've heard from one of the University of New South Wales, and now we're going to hear from the other university, the Australian National University, ANU, in Canberra. Today we've got with us AJ Mitchell, who is a senior lecturer, and he's also the program convener for the graduate certificate in nuclear technology regulation. Is that correct? Yes. AJ is also a renowned nuclear physicist, and looking at his research, I've noticed one topic that I find very fascinating. He's looking into the origin of delayed in fission products, delayed neutrons in fission products, which is something absolutely crucial to understanding nuclear reactor dynamics. So I hope to hear more, and please welcome AJ Mitchell. And please keep the question coming on Slido. We've got some really good ones so far.
Thanks very much, Patrick. Do we have a clicker for the slides anywhere? Yes, if I can grab that, please. Thank you. Is it obvious? Which one? Yes. All right. Thanks very much. It's wonderful to be here today. Thank you for the introduction. Thank you again to the organizers for the invitation to come and speak to you today. I'm a nuclear physicist. When I'm addressing audiences like this, I'm usually talking about the structure of atomic nuclei or their radioactive decay properties. But today, and noting that we're in National Science Week, I'm very excited to be talking about nuclear science training more broadly. And particularly, this will be a recurring theme for the day, addressing a skills development opportunity that is of critical national importance. I would argue, and many others in this room would argue as well. So if I could draw your attention to the slides here, we see a nice day in Canberra. One thing is it's great to be here. It was great to walk across and have a bit of sunshine on my face. We've had a lot of cold and wet weather where I come from. Usually I'm referring to Northern Ireland in that context, but not today. But I mean, despite the picturesque scenes, it hasn't been too pleasant in Canberra lately. But the striking feature at the forefront of the slide here, this is a drone shot of the ANU Research School of Physics. And the tower that's standing proudly amongst the rest of the buildings is home to our 15 million volt particle accelerator. And we'll talk a little bit more about that and the sorts of training that we do with the nuclear physics facility at ANU. AUKUS has been mentioned a few times. And I said it's a very exciting period to be a nuclear physicist in Australia. But I want to point out, I mean, this is something that has really shone the spotlight on the field in recent times. But it goes much broader than that. So this list is by no means exhaustive. But if we're looking, for example, the Australian Centre for Proton Therapy is on the verge of revolutionising cancer treatments onshore. Government agencies like ASNO are working daily to protect us and enhance security at Australia and internationally. We're on the verge of establishing National Radioactive Waste Management Facility. Specialised environmental measurement techniques are being used across a whole range of different areas that span defining global periods of time through to water management, tracing, all sorts of different applications. As noted a few times, we're at a point in time where carbon-free energy security is critically important, especially as in Australia, we're more strongly feeling the effects of climate change. But also very recently, we've had an emergence of Australian Space Agency and space industries that will continue to put pressure on terrestrial-based space qualification networks and associated infrastructure for being able to test sensitive electronics before they get sent up in space. So this is a very diverse list, obviously, but I think there are a couple of things that really underpin what's necessary to deliver these and many other examples that I haven't talked about today. One is a sovereign capability in nuclear science, and the other is training an appropriate workforce, technology-ready workforce, that can not only serve existing industry, but also be ready and available for emerging opportunities and be there to nurture those as they start to come online. So of course, Australia has a long history of nuclear science. The ANU, Research School of Physics, was one of the four founding schools at ANU. Its first director, Sir Mark Oliphant, was a nuclear physicist and was instrumental in establishing the Department of Nuclear Physics. We're now known as Department of Nuclear Physics and Accelerator Applications, but we've been conducting world-class research and education for over 70 years at the ANU. ANU is the only university in Australia that offers dedicated postgraduate education in nuclear science. And I make that very clear distinction, nuclear science, nuclear engineering. And I think one of the things, and already I've had conversations today, I feel like for a long time, nuclear science and nuclear engineering have been running in parallel. And now there's a catalyst that we're starting to have new conversations and really excited about seeing what direction things are going to go in the future. So if I circle here to a snapshot of what nuclear education at ANU looks like, we're really covering all the way through this pipeline. And we've just heard about how the sorts of lead times that are going to be involved in training a workforce that's going to be capable of sustaining nuclear-powered submarines. We're talking very, very long periods of time. In a typical year, prior to COVID, we would have welcomed between 200 and 300 high school students to the ANU every year. We had a bit of a slow period for a few years, but those activities are starting to ramp up again, around the sorts of constraints that we're working with. And that involved students who were as part of organised events, such as the National Youth Science Forum, the Santos Science Experience, but also schools around the Canberra region coming in and doing lab tours for a day, doing work experience, so on and so forth. Our undergraduate education, we have specialised courses that are embedded into our undergraduate degree programmes, but also from an early stage, students get that opportunity to come and do research projects with the academics. And those are quite often fruitful endeavours for us. We get students who come in first year, they do a part-time research project across the semester, but then you spark that interest. And then by the time they get to the honours stage, they come back and they're interested in doing more substantial projects which lead on to either great opportunities working in industry or beyond, or fingers crossed every now and again, some of them stay on and do PhDs with us. Then moving on to postgraduate education, we've got a diverse range of both coursework-based and research, higher degree by research options at ANU. Our graduate certificate in nuclear technology regulation is a new program. This was established in response to the AUKUS announcement at the end of last year. I'll talk a little bit more about that in a moment. We have a 1-year graduate diploma in science, 2-year Master of Science in Nuclear Science. Those are our coursework options. But for students who are interested in getting training more specifically in research-focused areas, we have 1-year Master of Philosophy and, of course, 3 to 4 year PhD programs. Full-time, of course, there. So we'll come back to postgrad coursework options. So our Master of Science in Nuclear Science, the current incarnation, has been around for over a decade. Used to be known as a Master of Nuclear Science. That has evolved a little bit along the way. But this is co-taught combination of ANU academics, friends from other institutions. I see some in the audience, very happy to. But what we really focus on here is laying the foundations in nuclear science. And you probably can't see on the slides with the resolution, but the sorts of courses that we offer really give that foundational understanding of nuclear physics, the physics of the nucleus, what happens when you take that collection of protons and neutrons together, poke it, all sorts of things that are interesting to me and hopefully interesting to the students as well. But then we cover different aspects of things that are more relevant to industry, like nuclear fuel cycle, reactor basics, so on and so forth. But each one of these courses has a strong lab component. Like really our ethos is that, yes, we can stand at the front of a classroom and talk to you, but by actually getting into the lab and plugging cables and seeing what signals look like, and hopefully not breaking expensive things, but breaking some things and learning from that. That's more an enriching education experience. And the courses that we have on offer for the Master of Science in Nuclear Science also come into play, say, with this graduate certificate in nuclear technology regulation. So we wanted a cross-disciplinary offering that was really going to cater for a really diverse group of people, professionals who would be looking to get some sort of upskilling initially in nuclear science. So the fundamentals course that the master's students do is one of the compulsory courses for the grad cert. Those students are all included in the same courses, by the way. But we also have a compulsory unit that's more focused on regulation, policy, and practice, and as well as that, a series of courses that span other offerings from nuclear science, but also we include nuclear weapons law from the College of Law. We've got a systems engineering course and some science communication courses as well. So the entry requirements for that program are bachelor's degree. You don't need to know any physics. Our motto is that we will teach you the physics. Knowing a little bit of mathematics is useful, but we're really trying to get a diverse range of teaching going on here. And it's at the heart of that is our heavy ion accelerator facility. Next year, we're going to be celebrating 50 years of beams coming out of our 15 million volt tandem Van de Graaff accelerator. But don't be fooled, it's not 50 years old on the inside. We work very closely with our technical staff. That machine has been constantly upgraded and improved as the years have gone on, so it's working as fresh as it was on day one delivery now. But our research groups typically span areas of nuclear structure research, the group that I work in. They understand nuclear reaction dynamics, so what happens when you take energetic nuclei, smash them together. That informs processes like fission and fusion that are important for a range of different industries. And the accelerator mass spectrometry, where imagine you filled up a venue like the Sydney Cricket Ground, right to the brim, full of sand, put 2 grains of salt into that. The AMS team can find those 2 grains of salt. Like mind-boggling precision, single atom counting that spans a whole range of different environmental applications. And one of the new things that's going to be coming online soon is a dedicated beamline for conducting testing for space equipment that's going to go into space. So weather in near Earth orbit is very different from the weather that we talk about on the surface. But if you're a company that's wanting to put a satellite into space, you want to understand how it's going to perform in that radiation-hard environment. This new dedicated beamline is going to be coming online next year. We welcome input from new industry partners to come and work with us with that endeavor. If anybody here is interested in that, I welcome conversations later today. As I say, we've got HandsOn Education. Really, all the students that we work with get in and they come in and they work with vacuum systems, they work with electronics, they get to drive the accelerator. We don't let them we don't shy away from letting the students really push the projects that come forward. And I'm going to skip over this. If anybody's interested in learning some recent nuclear physics, please let me know at the break. I will talk continuously about it. But I just want to flag as well, historically, we have given or allocated about 90% of the beam time of the accelerator to universities, Australian universities, and our overseas collaborators. But we're really actively seeking new collaborators now. We really hope to grow industry partners domestically and internationally. And one of the opportunities for doing so is through an Australian Research Council funded Industrial Transformation Training Centre, where we're looking to, as the title suggests, advance Australia's nuclear science capabilities. And really, the ethos here, the idea, the goal, is to develop the next generation of technologically trained scientists who will develop new technology, but then also have the social science understanding to be able to apply that to different areas that are relevant for Australia as we go forward. So again, this is something that I welcome anybody maybe might be personally or your organizations, if you're interested in learning more about this, I'd welcome any conversations during the breaks or through the rest of the day. And final comment, this has been mentioned a few times already, but building this nuclear industry in Australia, it's a massive task, right? And if it's going to be truly done properly and done well, I think this is an opportunity to look at a truly national approach. And say we have expertise in nuclear science, nuclear engineering already embedded throughout the universities and research organizations that we have in Australia. I'm really excited about seeing where we go in the next few years after this. So, thanks everybody.